Alright, and I did put the screen on. Good. Welcome to a Python lecture. So I'm excited to give you a programming lecture this week, because the last time we had a one lecture week, I had to do a non-programming lecture. So I guess this is keeping it even. So second Python lecture of the day, so please open up idle. Hopefully you're sitting at the same computer where you installed it last time. If not, go ahead and reinstall it. But let's get back here, because I'm going to teach you about a very wonderful library in Python. It's called the Turtle Library, and it is so cute, and it is very popular for like teaching people how to program. I'm a big fan. So let me teach it to you. So we will have programming today. But before we get there, I just want to go through one last bigger example with like taking input from the user, and then maybe those inputs were numbers though, and having to convert those types because that's important in Python. So let's do all that, and then I think then we're ready for the turtle library. I'm so excited. So let's make a program that asks the user for two things. We'll ask the user for two numbers, and like we'll save them into variables like num1 somehow, num2 somehow, like maybe the first number is a 2, the second number is a 3, and then our job is to output 2 cubed. Those are the two numbers that we got from the user. So let's do that. So let's make a program that does that and like outputs 8 as the final answer. Remember that power is the double star in Python. So let's make that happen. Let's try. In general, I know that this might be a little boring to you. We are learning a brand new language, so we have to go at least a little bit slow. Please stop me if you think I'm not going slow enough, by the way. We have to do some silly math for a little bit before we get there, but the turtle library will be very nice, I think. And I think you've noticed as well, like in general, when we're writing some arbitrary program, it's a lot easier to write it in Scratch, because like they've made a lot of stuff for us. In Python, we have to rebuild the wheel sometimes. So Python is a bit more of a low-level language, we say, because of that. Even though most people, once you learn more programming languages, people consider Python to be very high level. But we are blessed having learned Scratch first, I guess. And so let's get some numbers from the user. Remember that we're going to need to change those types. We're going to use that input function, if you remember it from before. And so every time we use the input function, we give it a little prompt. We get back the answer as a stir, right? So just a bunch of characters. Even if the user gave us, even if they typed like 42, we're going to get 42 as a stir, and we can't do math with stirs. So we have to convert that type by wrapping it with an int. We call that thing as a function, call the type we want as a function on the thing we want to convert. So let's make some code now. Let's get some numbers from the user with that input function. So I'm going to say file new to make a new program in Python. And I will save this in a new folder for today. It looks like it's lecture 14 today. So I will save this in a place so you can get it later, but you can save yours wherever. Try not to save it in the Python installation directory, which is apparently the default. I want to do it on the desktop. Lecture 14. And I will call this pow.py for we're doing a power computation. So here's the program. It's blank right now. And the first step is to get two numbers from the user, because we want to compute the first number to the power of the second number. So let's get that first number. We'll say input, enter the first num, and it's nice to leave a little space. So I said file new when I opened the idle program. And I was here and I said file, new file. File, new file, and that should open up a brand new window in idle. Alright, so this is the input call, and it's asking the user, once this gets called, it's going to ask the user, it's going to print this stuff out, and then we can type, and then we press enter, and it gets the thing, and so we can save that thing as a variable, call it num1, and set that equal to that. But this would be the stir version, this would be the quote number. We want a real number, so let's take whatever we get back from input and convert it. Convert it to the integer that we hope it to be. Okay? That is one line, in one fell swoop we can do it all. So this is getting the first, remember this is a comment, get the first number from the user as an int. we expect them to type in it to us. All right. Are there any questions about why this line is going to output enter the first num, and then convert it to a number, and then save it in a variable called num1, like this box over here? Does that make enough sense? All right. So I need to do that twice. We want num2 enter the second number as well, don't I? So then I have both of these. Now I have two numbers at once, and my job is to calculate one to the power of the other. Calculate num1 to the power of num2, num1 to the power of num2, and print the result. Okay, that's going to be the goal. So print, and then I have num1. I can say star star num2, and it will calculate and print stuff out. So that would give us the final answer. But if we wanted it to be pretty, remember you can give multiple arguments to the print function. You can say, oh, and by the way, Python doesn't care about single versus double quotes. Like, so this could have been a single quote. Stir. So print the result is, and then it'll enter in a space for us automatically if we just put a comma there. And then it'll print us our answer right back out. So that's going to be the program. Let me run it really quick so that you can see it working. Run module. Let me make this smaller over here. And so enter the first num, 2, hit enter. Enter the second num, 3, hit enter. Convert them both to numbers. Put them in those variables and output it that the result is 8. And of course, if you rerun this and give different things like 3 to the 4th power, it's gonna do the right thing for that one too. Any questions about any of that? So that's a good example of getting input from the user and doing stuff with it and converting types. So it all coming back to us. All right. So this was the game that we just played. It was like num1. Kind of read it backwards. You do the input, output your little prompt to the user, and then you convert whatever that is to the type you want it to be if it wasn't already a stir. All right. Are we happy with that? Are we ready for the turtle library? Is I hear a no? I don't remember. Okay. Let's do it. I'm so excited. So, all right. If you just search for Python turtle on Google, it will open up the documentation page. Python turtle. This is the coolest thing ever. It's the first thing. docs.python.org. Turtle graphics. We can make programs that draw stuff on the screen. It's beautiful. It's called the turtle library. We're going to import that, and you can run all these little functions. We'll talk about them. But there's so many cool things built into this turtle library. I'm excited to teach it to you. So, without further ado, let's talk about it. Why is it called the turtle library? It was invented as part of a very early programming language. This was supposed to be a library that taught kids how to program. So pretend to be a kid for the day. It's going to be very nice still. So the metaphor is that there is a turtle. Here's my best drawing of a turtle. Turtle, here's his shell, and he has a little tail, and it's got his, I think those are too large of feet, but I think you get the idea. Turtle. There's our turtle, and somehow, happy turtle, he got his tail dipped in ink. This is the metaphor. Don't know what happened. Not naming names. But also the turtle can respond to English or Python. He's sentient. He understands English and he can respond to our commands. And so we can ask the turtle to walk around with his ink-dipped tail and draw things for us and turn and pick his tail up and put it back down to draw dotted lines and things. So we can move wherever we want him to move. We can also tell him when we want the tail up and when we want the tail down. Down, of course, will make the marks, and up will not. With that, and loops and cool things that we'll learn about later, you can draw such cool things. For example, this cool looking star thing. And go even further than that. I'll show you even cooler things in this class, but not this lecture, I don't think. All right, so that's going to be the goal. Let's draw a square to start. All right, so let's try this out. All right, so let's draw a square. I'm going to make a new file. And I guess I'll call it square.py. Save it as square.py. This was a new file that I opened in the idle program. Did you not install this yet, maybe? Well, you have to install Python. Yeah, it's everything we did last lecture, if you go back to the video. Alright, so I'm going to save this, call it square.py. So a brand new program, and the very first thing, this is a library, so we're going to say import the name of the library, import turtle, and then we can do turtle stuff. Let's see, what's the easiest thing to do? So remember that when you want to use something in a library, you have to say like turtle dot something. So one particular function in the turtle library is turtle.position. It will tell you where he is. So turtle.pause for short. Where is that? There we go. So here's like everything that's in the turtle library. Turtle.position or turtle.pause tells us where he is. So there's always a concept of like a coordinate system, just like for Scratch. So let's print out the turtle's default position when the program begins. All right. Like turtle.position, whatever that is, let's wrap that in a print call to print it out. So I run this module. First of all, it's going to make a brand new window. This is where we're going to draw stuff when we run it. And then in the normal printing place, it prints that the turtle begins his life at 0, 0, those coordinates. All right. So there's our turtle. He's a little arrow. And to stop the program, we exit out of this window. Okay. So that's our first call to a turtle library function. All right. There are some other cool things we can do in the turtle library, like change the style of the turtle. Like, he shouldn't be an arrow. By default, the turtle should look like a turtle. So you can say turtle.shape and say turtle as a string, and he will become a turtle. And I would prefer that. So let's say turtle.shape and give the string turtle. So this is make the turtle actually look like a turtle. And now if I run this, there he is. There's a little turtle facing right. So there's also a concept of the initial direction for the turtle. So he's facing to the right, which we call east. So there's that. And yeah, let's draw a square now. Let me show it to you. So turtle's starting here at 0, 0. Let's plan out our square. So he's starting out at 0, 0, and he's by default facing east, facing right. So we can tell him to move in his current direction, and by default his tail is down. So we can just tell him to go forward. Go forward, Mr. Turtle, by like 100 units or something, and that will draw the bottom line of our square. Let's do that. Turtle.forward. Just go in your current direction. 100 units. Turtle.forward. 100. And if I run this, look at him go! We drew a little line. Isn't that cute? Any questions about this so far? So this line, this is saying, I don't know, Mr. Turtle, please move in your current direction by 100 units. All right? Whatever the unit system is here. Maybe it's pixels, I'm not sure. But that is going to move him forward, and then if we want to make this square, right, it's either, was that the top or the bottom? So we've got to turn him. Let's turn him to the left. So like we're down here. Let's say that we want to draw this line next, which is also length 100, but to get there, like if the turtle went forward, he'd be going this way still. We want to turn him to the left 90 degrees. You thought you never needed geometry again, but now you need it in this class. So let's say turtle. If we say turtle.left, you can give a number of degrees to turn. You can say turtle.left by 90, and that makes him turn 90 degrees. Turn left 90 degrees. So if I run that, he'll draw the bottom line. And then look at how he's in the position to move up. He's ready. He's in the right spot. So now if I made him move forward, you draw the other line. You see that? Isn't that fun? So let's see here. Yeah, so that's essentially how we're going to draw this square. We want to go forward some more. Forward. If I run this, so yes, I do want to save. Now we got that part. Again, we want to turn left, right? Turn left 90, draw another line. So do that twice more. So that is going to end up with a square. And save it before you run it, of course. But Look at him go, and then he wrapped back around and he drew a size 100 square just by saying forward, left, forward, left. Go a little bit, turn, go a little bit, turn, go a little bit, turn. Are there any questions about that? Isn't that kind of cute? And his position, of course, changes every time you move him. So like after you said forward 100, he's like gone in the positive x direction by 100 units. So if we print out his position again, you'll see that it's become, after that particular call, it would have been 100, 0 after we drew this first line. That was like over here. That was that coordinate. We started here at 0, 0, and this was 100, 0. And so we see that printed if we do it in that order. Like it worked out. That's everything. And so like this is what we kept doing. Here, all right, turn left again. This is 100, 100. There's always a coordinate system. Then we went forward, always by 100 units because we want a square. And then it's always left. And so this would have been what? 0, 100, something like that. But that's pretty much it. Let's see, what else do I want to show you? You can also change the speed of the turtle.speed. You can give him like a number or a string. Here. Turtle.motion speed, turtle.speed. And you can say either a number or like a string. So turtle.speed fast is something we could do to make him draw really quickly. So let's do it this way. Turtle, before you draw anything at the very top, turtle.speed, be like fast. This makes the turtle go faster than usual. Whee! And so we just drew that square super rapidly. But probably as you're first learning, you want to keep it nice and slow so you can watch it work. All right. So there's my program. Does it all make sense? Do we see how I'm drawing that square? It's kind of cute, I think. Let's see here. So if we're happy, I want to give this code to you and have you continue it. All right. So let me share this code with you. I guess the easiest way I can think of is, let me get it on like our code from class just really quick. So give me a second. I'll put it on our code from class page. Hopefully this will work pretty quickly. But I want you to try something while you're thinking about it, if you have it already. Try to draw a second square. But I'll get you this code really quick. Windows, desktop, F23, CSCI 1. Alright, so if you would like this code, I just put it on our code from class page on Canvas. So you can click any lecture or go to the top, and here is like code from class. If you go to today's lecture, you will see the code that I just put here, CSCI 1. And it's lecture 14, so I gave you the code early. I'll update it with the latest things later. But here is the code that I just typed. If it wants to load, lecture 14 though. It's trying really hard. Yeah. There it is in square. But yeah, what's the question? That's where the turtle draws. That's the turtle drawing window. I think it's this one. Oh, a different one? Yeah. Okay, I'll come and look after I give everybody this question. So I've given you the code. Try to draw a second square. So like we drew this first square. Draw another square somewhere on the page. All right, but like put it over here, or like put it inside, or like put it way down here. Draw a second square somewhere just by using up, down, like or forward, left. There's also a dot right in Turtle Land, but that's how it's going to work. If you would like to move the turtle, like, hey, face upwards right now, face downwards right now, you can say is turtle.setHeading and give an amount. So this is 0 degrees to face right. It's 90 degrees to face up. It's 180 degrees to face left. And it's 270 degrees to face down. If you want the turtle to pick up his tail so that like he doesn't draw a line on the way to the other square, you say turtle.up. And then turtle.down. We'll put him back down. So I think that's everything that I wanted to tell you. Remember to not name your file turtle.py because that's what the library is looking for, and it will like overwrite the library. We don't want that. That might be causing some issues if you did that. But yeah, give this a try. Draw another square. I'll give you like 4 minutes, and then I'll show you my way, and I can help anybody who's struggling right now. All right. So let's look at your window. Oh, that's just the output window. That's always going to be there. Yeah, that's the first thing you open when you open the file. If you were to print text, it would go there rather than there. Yeah. So I always print some text in my program. So you keep doing that. Yeah, I was trying to open up that doc. Well, I downloaded it. Okay, did you install it? I just do it. You downloaded it. Oh, okay, let's see. Yeah, you got close out of all those windows. I think you have it open many times. You're done with that. Yes. Close out all of those windows. Last time, I did go through all this. But now I'm start menu. Search your start menu. That is most of where I was. And I went to 5. I put it on our class, our code for class. You go to their own canvas. Not the class website, but oh yeah, it's called idle. If you search for Python, it does not open a program where you can write Python. Yeah. Okay. But if you don't do the dot up, it's gonna draw a line in between those squares, and that might not be what you want. I guess by default, it's always, before the program starts, it's turtle.setHeading 0 that faces them east. Maybe somebody's calling that secretly. But yeah, there's some really cool functions on the documentation page if you want to look into that. There's a way to draw a circle, etc. Change the color. Minute or so. All right. So I will draw another turtle, or not another turtle, but another square. And I think I'll draw mine below the first one, because like after you're done drawing the square, like the direction's already down. So I'll just be like, draw one down here or something. That seems easiest to me.
Oh, you didn't want to square around square?
That also works. Now you can draw it however you want. But I'll just do one down here because it's less typing for me. But it will show the issue with up and down, though. That's for sure. So right now he's facing downward. So let's draw a second square. And so if I like want to put him in position, what could we do? I guess last time I drew a square over here. Let's do it that way. So then I can show you the set heading. Let's draw like a square over here. So let me tell the turtle to turtle.setHeading 0. And let's watch this work. Set heading 0 makes him face east always. He was facing down if I didn't have this. But I said set heading 0 to face east. And now let's draw a square, let's say over here to the right somewhere. So like get outside of the first square and go over there. That's going to be like turtle.forward by a lot, right? Turtle.forward 150 or so. But if I just say that, by default the turtle's tail is down, and so he's going to draw this ugly line between the squares. Like this is where maybe I want to start the square. So in order to get here without drawing a line, I need to pick the tail of the turtle up. Alright? So I will say, let me put some lines down here so it can go up here. I would like to say before I do this, pick the tail of the turtle up. So turtle.up, we'll be like, pick your tail up. Now while his tail is up, go forward wherever you want to be without making marks. And then put your tail right back down, because now you're in the right spot. Put your tail down. And these three things in that order together, we move over here and we do not make any lines, and then we put our tail back down so that we're ready to make new lines. Does that make sense? That's the trick. And then we can draw a square. Let's draw a little baby square, like size 25. And so it's going to be a bunch of turtle.forward by like 25, and it's still always turn left 90 degrees. That's how squares work, right? Save. And so I got the first part, and then let's just keep on doing that. First line, second line, third line, fourth line. I don't need this left at the end. So like a big square and a baby square. Separated though with that up. Are there any questions about that? Does that make enough sense? So cute. So I hope you see like the potential that this could have once we learn cooler things in Python. Like we could make 1,000,000 squares, random squares. It would get really nice, I think. So let's back to the code. Are we ready for triangles? This is a geometry class today. So all right, let's draw an equilateral triangle. So if the turtle starts here at like 0, 0, and I want to draw, maybe this is the bottom part of the equilateral triangle. What does it mean to be an equilateral triangle? I got a triangle, and every side, right, is the same length. And that also implies that every angle is the same length. So like these are all, like whatever this angle is, they're all the same over here. And all these lines, they're the same. What is the angle at every angle in an equilateral triangle? Do we remember? 60. Yeah, it's got to be equal. So 180 over 3 is 60. So this is a 60-degree angle at every corner. So in theory, right, we got the turtle. We say go forward. Let's say this is like a size 200 equilateral triangle. Let me make a new file. I'll copy and paste most of this. I'll call it triangle.py. Triangle.py, but I'll delete all the square stuff, of course. There. And now we're going to move forward by 200 units. That's right, new file for a new program. And so this is the parts that are still the same. So go forward by 200, then we're ready to turn, right? What we did last time was we turned. So turn left is at 60. Turtle dot left by 60 degrees? Question mark? That's not right. You see how the turtle's going to go off that way? Something's wrong there. And if I went forward by 200 right now, it would also still be wrong. So it's not left 60, even though that's the angle there. So we need to talk about that. Because that's not an equilateral triangle. That's like getting ready to draw a pentagon or something, I think. That's not good enough. So there's an issue with this. This is not the right angle. Let's talk about this. So, all right. The turtle was going this way. We need to turn him to the left so they could start going this way. Do you see the problem? We went turn left by 60, but we need to go by more than that. This is 60 over here, but this is how far the turtle needs to go. Do you know how to solve for this angle? You remember geometry class? It's 180 minus 60. This is a line. You thought you'd never need geometry again. But here you need it. This angle that we want to turn the turtle left by is 180 minus 60. It's bigger than 60 degrees. See that? Because he was facing this way. We want him to face this way, so we got to turn by that entire amount. I hope that makes sense. So it's not turn left by 60. It's turn left by 180 minus 60, or what, 120? But this works too. Python can do math for you. You can just write it like this if that's easier to think about. And now, if we go forward 200 after that, we are in the right spot. And if we just do this once more, it will work out. Because again, the same issue applies. So turn left by that amount and go forward by 200. And we have ourselves a nice equilateral triangle. Any questions about that and the difference between that and the square? That was kind of fun, I think. And I encourage you to try to draw a second equilateral triangle. Use that set heading and everything. But I want to move on to the hardest problem for the day. Are we ready for it? All right, this is going to take a little while. So here is a fun program. Let's say that, I don't know, you're all me right now. I'll give you an assignment that's very similar to this, so think about how you draw yours. But let's make a program that draws my initials. All right, so my initials are L and N. So we want to draw this. We want to draw an L. Let's see if I can get this in a spot where I can write diagrams. I want to draw an L, and then I also want to draw an N. Like this. Trying to make this as precise as possible. I think you can see what's going on in it. That's not pointy enough for me, so let me fix that. Boop. That's kind of what I want to do. This is what I want to draw, right? Something like this, where it's all straight lines. Just imagine that these are straight lines, except for the slash on the end, of course. So that's what I want to draw, and I have to plan this out, right? If I'm going to make a program to do this. The L is very easy. It's just part of a square. We know how to do that. It's a rectangle. It's a little bit wider than it is, it's a little bit taller than it is wide. Let's pretend that, like, I want this to be size 200. I want this to be width, like 125. That works out. We're going to do the same for the N. Like, this has got to be size 200. This has got to be width 125. We'll make each letter as wide as the other. That's fine. What else do we need to plan out? Like, what's our starting point? Like, maybe we start here or something and then start, like, moving, facing downwards, going forward, stuff like that. We also have to figure out what do we want this gap to be. If we want to precisely specify, like, how big should this gap between the letters be? Let's pretend maybe it's going to be size 40. Length 40 or something. Not drawn to scale. So that seems like a good plan. Let's say we start here, wherever we are, we start here. And then we move down, we face downwards, and then we're ready to, like, draw that. Then we can, like, turn left, draw that. That would work. So let's draw the L right now, but the N is going to get difficult. All right, start planning in your head how you might do this. But let's make a new file. I'll steal the triangle file, at least most of it, and I'll call it initials.py. Eventually, I'm going to ask you to draw your own initials. So let's see here. That's good enough. And then let me not have it go fast. So a very simple thing that a nice thing that you usually want to do in programs, like you don't like this line anymore, you don't want it to run, but you want to keep it, you maybe want it to run later, you can make it a comment. This is called commenting out a line. Now it doesn't apply. Now it's not code anymore, but it's very easy to make it code again. Just delete the comment. That's called commenting out a line. I don't want the speed to be fast right now, but I want the ability to come back to that. That's pretty nice. And so, all right, I want to maybe draw the L, like not in the middle of the screen. Like if I were here and I face down and draw the L over here, like let's center this. Like let's put the L over here and then the N right here, something like that. So I would like the turtle starts here. I want to like move him into position, move him up there before I'm ready to start writing my L. All right, that's what I would like to do. So that's what I want to do, something like that. So with that in mind, let's start our program by moving the turtle into some position that is nice. Be like, let's start him moving to the left, right? I want to move him to the left first. So let's set the heading to 180. So by default it's 0, and then it goes counterclockwise. So turtle dot set heading 180, and then now if I say turtle dot forward, he's going to start moving to the left. Does this make sense? So that moves him over there. But I don't want him to make marks either while I'm getting him into position. I'm not ready to draw the L yet. So I'll say turtle.up. And then maybe we want this to be like 200, let's say. So like get over here with your tail up, and then go up a little bit, and then you're ready to start drawing the L. Because we want to get him at the start of the tip of the L. That's our goal. Like right here. That's where we'll start our drawing. So let's move him up a little bit now. This is a zoomed in version of what we want. So it's like, all right, you're facing left. Let's turn you right now, turtle.right by 90 degrees, and then we can go forward and move him up. So I hope that is somewhat logical in your mind too. So he's right there. Let's say turtle.right by 90. And then if we say turtle.forward by a little bit, he'll move up. Turtle for like maybe 100. So let's watch that work. There he goes, up, and now he's in the right spot. See that? And now we're ready to start drawing that L. And that's where we want to be. So now when we're in position, we're ready to draw now. This whole part was like getting the turtle into position. Now we're ready to draw. We can say turtle.down. We're in the right spot. Start making marks now. All right? Any questions about that? We just wanted to get into a nice spot to start our L. Like try and make it as centered as possible, in theory. Because now we're ready for that L. All right, next step, draw the L. How do we do it? So the first step, right, if we wanted to start here, if we were starting here, we want to face downwards. The first step is to face downwards so that when we go forward by 200, we'll actually draw the L in the right spot. So we need to face downwards, which is set heading 270. Set heading 270. That will have us face downwards. Alternatively, we can just like turn ourselves. We can go left or something. But set heading 270 works for me. Set heading 270. And so now if I run this, you'll see that he's facing down. There we go. Turn him around. Face 270, regardless of where you were before. And now we can start drawing our L. We go, what? Forward by 200. Let's do that. There he goes. And then we want to have him turn, it's always from the perspective of the turtle, so turn left by 90 degrees, and then go forward the width, which is 125. So left 90, forward 125. Forward, not 200, oops, not 200, but 125. And that will give us an L. Whee! Does that part make sense? Does the code so far make enough sense? Get into position, start drawing the L. We did it. Because now we need to get ready to draw the N. So we need to like give some space. We said we're going to have 40 units of space in between the L and the N. So I want to go forward, right, in the current direction. That is the spacing direction. go forward by 40. But pick your tail up first. This is the space in between the letters. So if you pick him up, then if he goes forward, he's not going to make a mark. And so now he's at the right spot to start drawing the N. He's at the bottom left of that N. So now that's where he is. And so we can put his tail back down because we're ready to start drawing again. Turtle dot down. Now we're ready for the N. Draw the N. All right, any questions about any of that so far? Get into position, draw the L, draw the space in between the letters, or don't draw the space, I guess, and then draw the N. Because we can do the first line pretty easily. That's not too bad, right? It's just like, all right, we were facing this way. All right, now, just like turn left 90 and go forward 200. That'll get the left side of the N. That's fine. So turtle dot left 90, forward 200. And then we're going to get stuck. There's the L space. We got the N. Now the question of the day is, what in the world do we turn by? Oh man, oh man. So the turtle's direction right now is that. Does that make sense? Facing that way. We need to turn him this much, by whatever that is, so that we can go forward by who knows how much that is either. Like, we have an unknown, right? We have a few things unknown. We don't know this angle, and we have no clue what this length is of this middle line. We don't know how much forward to go after we guess that angle. There's two unknowns right now. Any questions about that? We have to do some math. Does it make sense why we need to do that math? All right, let's do it. So, notice we have a right triangle here. Hoo-hoo. So, all right. We can figure out this angle right here by using one of our trigonometric formulas, right? This is the angle we want. We know the opposite and the adjacent, so we could use tangent to find the angle, or inverse tangent, really, to find the angle. We know that whatever this is, right? Let me see. How do I want to move this? I need room. Can I make this small? I can. Nice and small. I guess we don't even need this anymore. I know that whatever this angle is, the tangent of it, tangent of question mark, is equal to the opposite over the adjacent, 125 over 200. So I can solve for the angle by taking the inverse tangent. Do we remember all this? So I can get the question mark is equal to the inverse tangent of 125 over 200. All right? If only I knew how to calculate the inverse tangent. That's what the math library is for. You remember that those were there? So let's go back to the math library in Python. Where's that documentation? So we're in the turtle library right now. Python math this time. Where's tangent? Tangent. So there's a normal tangent, and then there's the inverse tangent, also called the arctangent. So atan. We want to say math.atan of something. All right? Math.atan of this 125 over 200. So we're going to import the math library, say math.atan 125 over 200. All right? And that's going to give us the answer back, but it's going to be in radians. We only can turn the turtle with degrees, though. So this answer is in radians. So we need to convert it to degrees in order to give it to the turtle and turn by that amount. All right? So there's a way to do that. I think it's just, you just say math.degrees, give it something in radians, and it will create the degrees of it. So we're going to say math.degrees as well. Does that make sense? That will give us that angle. And then notice that we don't want to go, I guess it's turn right. We don't want to turn right by the angle. We want to turn right by 180 minus the angle. That problem with the triangle all over again. That's going to be our goal. All right, so with that in mind, let's import the math library and make this happen. There's a lot we had to worry about there. So, okay, import math as well. It's customary to just do it up top, even though we only need it first down here. And then now we need to figure out this angle. What better place to figure it out than in a variable? Let's call it angle. Angle is equal to math.atan, the inverse tangent of 125 over 200. Nice. And so right now this is going to be in radians, but I want to take whatever this is and create degrees out of radians. So I say math.degrees. Just like I'm saying input and then immediately making it an int. I can take this result and immediately call math.degrees on it to convert it to 2 degrees from radians. Right? So that's going to be the angle. And I want to make the turtle turn right by not this angle, but 180 minus the angle. All right? Turtle.right 180 minus this angle, whatever it is. We don't need to write it down. Python will solve for it for us. And that looks right to me. Oh yeah, so it's ready. The turtle is ready. And now the question is, we need to have the turtle go forward by the angle that is this little diagonal on the L. How do I find that L? Any ideas? Any more trigonometry secrets you could try? Hint, this is a right triangle. I got 2 sides of it. How do I solve for the third? Yeah, so the hypotenuse. So I'll use the Pythagorean theorem, right? Pythagorean formula. Let's do it. So I know that a squared plus b squared equals c squared, right? So, all right, 125 squared plus 200 squared equals L squared. And so just square root both sides. L is equal to L squared is equal to, right, 125 squared plus 200 squared. And if I just take the square root, that gives me the L. We know how to do square root. That's math.sqrt. We know how to square things. That's ** 2. We can solve for L now. All right, let's do that. Have Python do it for us. L equals all this. Math.square root of 125 squared plus 200 squared. Just simple as that. And we were already in the right direction, so just say turtle.forward by whatever L is. That's the beauty of variables. Let's go forward by that amount. Who knows what it is? We can print it out if we wanted to, but Python will just do it for us. And then we know that we want to go straight up now, so we could say set heading 90. Or we could do what we just did. It's going to be turn left by 180 minus that angle that we solved because it's symmetric. But it's to the left this time. Or you could just be like set heading 90. That would also work. And then we're home free because then we just go straight up. We know exactly how tall the end should be. We just did that, size 200. Boop. And so it's turtle.forward 200 at the very end. And that is my initials. I'm so sorry if there's an M in your initials. You have to do that twice.
Or if there's a curve.
Exactly. Or you can just do it like straight lines if you wanted to. But are there any questions about this? This was a great example of several libraries solving problems with Python and getting an interesting result. It's a great program to study. Any questions about it, though? All right, so just like every math class, if this is technically a math class now, you always learn the hard way before you learn the easy way. There is an easy way. If you just pick out the coordinates, there's a turtle.goto. You solve for the coordinates yourself, and that's actually easier in this case. You can say turtle.goto, and he will just warp to whatever the coordinates you give him. So let's go to the turtle library. There's a goto function. It's also called set pos or set position. But if you just give 2 arguments, I want, hey turtle, go to 6030. Hey turtle, go to 2080. Go to some coordinate. And he will just warp there regardless of his current direction. So watch. I'll be like, turtle.goto 00. And then watch him just warp to 00 regardless of where he was. Whee! So that's the easy way to use this goto and calculate coordinates ahead of time. So it was much more educational, though, to do it the other way. I think you'll agree. So, yeah. food for thought. Any questions about that one? I think that's all of the lecture stuff that I wanted to talk about. Yeah.
Is there a way to see like the coordinates on the Python total graphics thing? Like to see like where everything is?
That's a good question. I do not know how. I do not know how. If you read through the documentation page, it might show you. But if nothing else, you can always print the position after moving. You can say, where are we now? Print position after moving again. Where are we now? You can always ask the turtle where he is. So that's one way to solve for it. I don't know if there's a way to like turn on a grid or something though. And that might be easier, but I haven't heard of that. That's a great question. Any other questions? All right. If we are happy, I have several things to talk about since I won't be able to talk about them during our midterm next time. By the way, the midterm will be here. You just come to class, click this link, and it will be available during the time of the class. And then you'll take it. But I have so many things to talk about. We have an essay, a programming assignment, several things, an extra credit opportunity. Oh man, oh man. So, all right, let's get through all of them. Normally I do this like half today, half Wednesday, but we can't. So let's do this. Several things, because we got these due this week, right? So, first new assignment, essay. I would like you to write a very short essay. I'll give you 2 weeks to do it because of the midterm. But here is your prompt. So I've given you a little article. It's about a machine called the F23. So please read this article. It is a very unfortunate, sad story about computer science. Unfortunately, you have to read it and learn from it. So read that article and write a response to it. Talk about any false assumptions that were made. This is like a device that people made, and so some companies made some mistakes. Did they make any assumptions that were wrong? You can also look at the Wikipedia page, but don't cite Wikipedia. Remember to cite what Wikipedia cites. Maybe tell me what you would have done differently to prevent this problem, or disaster, really. So that is your essay. Structure it however you want. I just want a response. Talk about false assumptions as well as what you would have done to fix it if you were the person in charge. It will make sense once you read the article what the problem was, I think. Any questions about that? So just 500 words, not too much, and you got 2 weeks to do it. No citation requirement or anything. Just the words. What I'm looking for. But you have, as usual, the rubric. So that's the first thing. Good for that essay? All right. Next, we have a programming assignment. So this will be due week 10 as well. I would like you to make your initials. So your initials as well as some numbers too. So let's do, I want you to write a Python program that uses Turtle Graphics to draw your initials, and then also the year that you want to graduate, you intend to graduate. So like for me, I graduated in 2020. So just the last 2 digits is fine. So I'll say LN20. Maybe you are AB24. I'm not sure. Or whatever. So that's the idea. All right. So remember the numbers as well. I want initials and some numbers. But that is the goal. You don't have to use the fancy angles like I did. You can use goto. You're also not required to use curves. If like there's a C in your initial, you can just make it blocky. That's fine. You can also learn how to use the turtle.circle function. It will draw a curve for you. I encourage you to look into it. I'll teach you how if you have questions, but not required. It's harder. You can just make curves using straight lines if you'd like. But like here's my initials. Like I would also then, to complete this assignment, draw like a 2 and a 0. So don't forget your digits. Any questions about that? That's pretty much what we did today at the end. I want you to do it now. And so you'll look at my code and make it yours. And yeah, as usual, upload a video, like go through your code. A number of us have not been able to get our voices on our videos, and from now on, I'm giving you a 0 if I can't hear your voice. All right? I want you to explain it, because otherwise I don't trust that you understand it. All right, so explain your video, show me your code, all that fun stuff. All right, that is the goal. Are we good with that? So initials and graduation year, last 2 digits of your intended graduation year. All right, and for those of you who have programmed before, from now on, I want you on the Python track. I want you to learn Python too. So from now on, do the assignment that I just assigned. All right, but please go above and beyond because I know you can do that. Make it colorful. make it pretty, use the curves, whatever you want. So this will be also due week 10. I think that's everything that I wanted to say. So week 10, initials, graduation year for everyone. All right, so let's see. Let's do the extra credit next. So I have promised you extra credit, and I like to give it around exam time. So here is your extra credit. Here's one extra credit opportunity. I'll give you another one later in the class. I would like you to learn another programming language. Why not? So please learn JavaScript if you would like to. This will be worth up to 5% extra credit. And I'd like you to use the Khan Academy website, make a little account, and go through the JavaScript course. So that's a very popular language in addition to Python. Those are probably the most two popular languages these days. So I won't be teaching you this one. Learn it yourself. So if you would like 2.5% extra credit, go to this page, make an account, and complete, like there's a bunch of units and stuff, and like you can see all these things. But for 2.5% extra credit, complete every lesson, project, challenge, up to and including the variables section. So all the way, intro to programming, drawing basics, coloring, variables. So complete all of these and show me that you did it. Because it'll be very easy for you to show me that you did it, because these things like start filling in. You'll have completion marks. You see how that star is like got a little blue line and below it? That line would go to the completely, like all the way to the right if you completed that. It would tell me. So that's how you'd prove to me that you did it. So if you want 2.5%, do that. If you want the full 5, go up to and including the interactive program section, please. All the way down, past variables, animation basics, up to and including interactive programs, and just have every icon display that you've completed every task, including the lessons, and just upload to me a video as proof that you did them all. That's your extra credit assignment. So please upload a video where you just scroll through all that and show me that everything is checked off. Okay? That is your extra credit opportunity. I'll give you like a month to do it. This will be due October 20th. This is one of our rare midnight due dates because it's extra credit. It's fine. But there are no extensions for extra credit assignments, just like there's no extensions for exams. So just keep that in mind. This is the hard due date for everybody. So that's that. If you already know JavaScript, it would be cheating to have you do this, right? So just talk to me, and we'll find you another language to learn. So we'll figure it out. Maybe Code Wars is a fun website that I like. So we'll find you something, but obviously it would not be fair for you to do all this because you could do it in an hour. So yeah, that is your extra credit opportunity. Any questions about that? So we're almost done. One last thing to talk about. All right. The last thing is just for me. You know how in the class, like they made me go outside and they had you guys fill out those little forms about me. I will not like hear your responses until after grades are due. That's the whole point, right? It's all anonymous. So I would like to give you an opportunity to give me specifically feedback while we're still in the class together. So I've made a little Google form. I'll call it mid-semester anonymous feedback. Obviously, this is not for a grade, but if you have anything you'd like to tell me, I'd appreciate your thoughts while there's still time to, like, if there's a problem, I could change it. So, like, click here and fill out this little Google form. It's like, give me 3 things I should keep doing, stop doing, start doing. What would you change about the class? Stuff like that. I would appreciate your input if you have any. And then I will see this before we all leave. And I can fix something if there's something very big that's a problem. So, yeah. I think that's all that I have to say. Any questions about that? Just please fill it out if you have anything you'd like to say. I'd appreciate it. I believe that is everything. Any questions about any of that? So that was a lot of information at once. Sorry. Yeah. Oh, yeah. So I'll just check the midterm info page. I'm going to give you an essay, and then I'm going to give you a bunch of questions about stuff on this cheat sheet. That's going to be the breakdown, pretty much. So that's my hint to you. Okay? Does that work? Yeah. Any other questions? So remember, this is during class. We'll do it all on a Canvas on Wednesday. And I think that is officially everything that I would like to say. So the rest of the time is yours to study, start on any of these assignments, and ask me questions.